All right, well, thank you for joining for our panel. And so, in case you're wondering if you're in the right room, this is the billion-dollar panel. We're talking about GraphQL nullability, the hottest topic these days. It's so hot right now. And we have some excellent panelists here. So excited. I hope that some of you got a chance just now up in Skyline to watch a very relevant talk from Jordan here. And so, but we are going to be, not assuming prerequisites, because this topic is also a little bit esoteric. It's a little bit down in the weeds of the GraphQL spec, but that is really exciting to me because I think that it shows maturity of GraphQL. We are going back and like revisiting with the benefit of hindsight some of these nitty-gritty design decisions and stuff. And so so also we're gonna have some discussion, and we also want to open it up for questions from folks. And so there is a QR code that I'm gonna pull up here. There we go. And so, as we go, your questions, you can add them there, and we might not address everything, but hopefully we can discuss some of those as well. So this is interactive. We invite your questions. Let's see. So let's go ahead and start us off. Yeah, and we have an empty chair here. We were gonna have Lee, but is Lee? Did Lee made it in here yet? He's gonna sit in here with us. Lee, are you in the room? He's outside. Okay, he hadn't made it in. But okay. That's okay. He's important. So we'll go ahead and jump in. So the first question we want to talk about is, why are we talking about nullability? Doesn't GraphQL handle this? What is different about nullability in GraphQL? What is distinct about it? And let's start off with Jordan here.
Hi, I'm Jordan. I work at Meta on Relay. And I think one of the key distinctions between why nullability feels different in GraphQL than it does in other languages is that we've sort of collapsed down the idea of error and the idea of null in GraphQL. And we've got a lot of benefit from that in terms of resiliency and being able to absorb errors. But I think it's this entanglement of null and error that has sort of created null as a special and more complicated thing in GraphQL than in other languages. But I will maybe pass it down if anyone else has any additional context to share.
Awesome. And so one quick thing that we need to do is we have to do null check. And so on our panelists, you just always check for null. That's just a rule of programming. So we have a hat. There is some cards in here, and most of them are okay, but one of them's got a null. And so so we'll see what happens here. So
pressure's on.
Yeah, let's pull one. What do you got?
I got to check.
All right. 200. Okay. Let's keep Jordan. Okay. Awesome. They didn't know I was going to do this, by the way. They're like, what is he doing? Okay, so next question. Let's talk about so in GraphQL, one of the things that is different is the default is that things are nullable, right? And so why is that? I'm gonna give it to Lee.
It's like the real answer you want is from a person named Dan Schaefer, who is one of the original teammates on the GraphQL team, who is the most emphatic about this. In fact, you can occasionally find issues on the GraphQL spec repo where somebody asks this question, and Dan will show up with like a 2-page essay on exactly why. And a lot of it boils down to because anything can fail at any time for any reason. And if you think otherwise, then good luck in the 1 in a zillion chance where it breaks, and it breaks catastrophically, and your client falls apart. And that is true. And there's another reason, which is a sort of API design and evolution reason, which is if you are ever unsure about the scope of a type, you kind of, from an API design point of view, want to start where you never have to broaden it. Because if you have to broaden it, you break things, right? Like if you say, this can return a cat, you're like, great. And then later you say, uh-oh, it turns out sometimes there are dogs. So update to the API. You can get cats or you can get dogs. And you've got a shipped iOS binary, which does like, cat dot, some feline trait. And you get, feline trait does not exist on dog object type, and just hard crash, app crashes. Oh no. And then of course the other version of this is you check for that thing and it says, oh, cat or null. And it says, you cannot access anything on null, hard crash. So the default of nullability is to protect against this case, that in the future you may have scenarios where you might want to narrow that. We have the non-nullable type. But if you ever realize, like, oh no, I started with everything non-nullable, there's a handful of my types that need to be now changed to nullable. That's where this jumps in and bites you.
Yeah, that's excellent. I mean, there's obviously good reasons to why we do this, right? Yeah. And but it's cool to see the historical, perspective. But as you said, everything can fail, and so we're gonna have to do a null check. And quick. Okay. Oh. Okay.
Is it an error null?
No. Yeah. We're gonna have to check the logs. I don't know if this is an error or Yeah. I don't know. But in any case, it's a null. So I think yeah, you gotta go. Sorry. Sorry, Lee. Leeb is not a function, turns out. So carrying on. So building off of that. So why don't we why don't we use non-null more frequently in our graph? Like what problems do we run into? Janet, take this one.
Sure. Hi everyone, I'm Janette. I work also at Meta on our internal only mobile GraphQL client. So yeah, I think Lee touched on this a little bit, right? But it's sort of like if you type something as non-null in the GraphQL schema, what you're saying is, I as a server promise you, client, I will never send this down as null. And it's you should watch Jordan's talk because I think the visualization helps. Is you can really blow up a lot of usable data if you do that. So it's and you're sacrificing ergonomics for like render at all costs. So like by typing everything as null, you like really this is like as careful as you can be, right? You're gonna check everything. You have this paranoia. Anything could go wrong. But that is the way to make sure that your blast radius is as small as possible. So I think that's why currently, or was that the question? Okay, yeah. That's why everything is nullable. Yeah.
So we have to do a null check. True. All right. So, next question. Let's talk about errors a little bit, and talk about how errors, how they're handled, and don't most clients in practice, if there's an error in the error list, how do we actually handle it? Like, don't we usually just throw everything away? And how significant is partial success? How important is that? Alex, you want to talk about this? Introduce yourself.
Oh yeah, I'm Alex. I worked on the original client-controlled nullability proposal and implementation. I think it's a mix. If you look at like survey data, a lot of people are hitting GraphQL endpoints with what we've been calling naive clients. Benjie has a little more of a distinction here. But a lot of these naive clients, if you're just curling a GraphQL endpoint, a lot of them, if they see any errors, they drop everything. And then some of the more smart clients, Apollo and Relay and things in that realm, allow users to handle stuff, or they handle it automatically with Relay's React's error boundaries or whatnot. But it's still a little iffy. A lot of these smart clients have a normalized cache that if something comes in with an error, then they can't trust the data that's coming in, so they can't feel comfortable storing any of it, which is a problem we're probably going to talk about more later.
So now, with most problems that we run into with GraphQL, we have to think, can this be solved without resorting to changing the specification? And so I would love to hear perspectives on this. Benjie, we've not heard from you yet. Some thoughts?
It's an interesting one, and partly it comes down to thinking about what the actual underlying problem is that we're solving. And there's a few things here. Like there's the concept of something that we've made nullable because an error might happen here, but we'd never expect it to be null in general. Like in Jordan's talk, like we all have a best friend, so best friend's going to be non-nullable, but also if the best friend service goes down, then we need to handle that. So we make it nullable, and we've got this like gap there. So we do need something to fill it, and when we look at how to do that, one option is to do directives, which we can do in the existing spec, but it's not particularly ergonomic, and also it doesn't necessarily fix all of the problems that we have. And one of the other problems that we have is an issue that clients like Relay, Apollo, Urkel have when they have normalized caches. And that is that if you have the server honor these non-nulls for you by blowing up all these selection sets, then it's no longer safe to write the result to your normalized store, because it might overwrite stuff you already have with a null, and that stuff shouldn't necessarily be null. It might blow up existing data that you already fetched. It's just not safe to mix with your existing data. So if there's any errors, especially if they happened in non-nullable positions, all of a sudden this can no longer be written to your normalized store. So this is another thing that we need to solve.
I think the reason that it feels like it needs to be, certainly it needs to be something that is in this contract between clients and servers, is that it's information that the server knows, is best positioned to know, that the client somehow needs to see, and today it can't. Today the client is blind to what this nullable field means in terms of what expectations it can have about the data in the non-error case.
And we forgot to do our null checks. Dun, dun, dun. All right. Benjie, you haven't. Phew. All right. We still have a panel. 200, okay. Partial data is okay. So speaking of that, so we have one question from our Slido. By the way, if you came in later, we have a QR code there, and so you can ask questions and contribute. So we have several questions. One of them has 2 thumbs up, so that means it's been upvoted. This is from Anonymous. Fairly new to GraphQL. I'm having a hard time grasping how and when errors arise for some fields on a query, but not others. Wouldn't it all work or all fail /error? Let's see. Janet, maybe?
Yeah, so I'm not a server engineer, so I don't know the spec like the back of my hand. So generally, right, in your GraphQL, you have resolvers for your different fields. So a resolver for a field might throw an exception. So that specific field has an error, but the rest of your response is okay. Like we were able to resolve the rest of your query. So that is when you have a partial error. there are also, versions of errors where you might want to throw out your entire response. Or you might say like, oh, I don't want to deal with a partial error, so I'm going to treat it as the whole thing is cursed. But secretly, or you could salvage it. There's a lot you could salvage. And like, the way it's described in the spec is, these errors are associated with specific fields.
And I think originally, one of the things that Null said to us previously is is that it came down to the Facebook newsfeed back in the day, right? You wanted to be able to render certain systems might be unstable at times, and you still want to be able to render the rest of the web page. Otherwise, you're losing business value. So yeah, it's really, really important to handle.
Now, well, one of the the first ways that we looked to address this was known as client-controlled nullability. Some of you may be aware of this this RFC that kicked off by Alex here. I think one night after after a happy hours, we talked about nullability, and he just hammered out this RFC, and that started this whole discussion. But now we are we're not looking at that specific direction anymore. Why is that?
Yeah, I mean, I think it went through a few iterations, and new problems kept coming up, and sort of sub RFCs kept spidering out. At one point, we were like, we're gonna reel this all back. We're gonna strip everything down and try to start from scratch again. And after a few discussions there, I think we decided that it was more of a fundamental problem. Client-controlled nullability was intended to sort of patch over the nullability issues that we've been talking about and allow the client to have more control. And we initially didn't think it was going to be solvable from the server side. We thought it was going to be breaking, but after some discussion between the people you see here, I think they decided that it was actually doable.
I just wanted to say that this sort of idea of semantic nullability actually has a direct through line through client-controlled nullability. It was thinking about this fact, like, oh, if the client could opt out of null bubbling, that was that sort of aha moment that was like, oh, if we could do that, then this whole other possibility of letting the client handle errors is unlocked. And so there's like all that work sort of like fed into the work that we're doing now.
So you mentioned something called semantic nullability, and this gets me curious. So if we're not doing the client-controlled nullability as we started off in the RFC, is there an ergonomic way for clients to not have to null check everywhere, or null check both before and after every panelist talks, and just null checking out the wazoo? And if so, what's the catch?
I mean, Jordan just did a talk on this, so yeah. So I think you need this way to indicate that there's this null only on error, and once you've got that ability, you can do so much more, right? It's more expressive. It fills this gap, and if you combine that with the ability of like a modern client to intelligently process your GraphQL, not just like a window.fetch that just gives you the data, but like a client like Reilly or Apollo, Urkel, GQL to Dar, and so on. If those clients can do things for you that handle these things in a more natural way. So for example, Reilly, it can make it so that when you read a field or where you read a fragment that has an error in it, it can tell it to actually throw an error. You're not just reading it as data anymore. You've taken something, you've thrown it on the server, GraphQL's caught it, and it's put it down to null and an error on the wire. Your clients then receive this as just data, and then when you read it in your code, all of a sudden you've turned it back into a thrown error again. And then you can try catch, or you can use a React error boundary, or you can do any of these other different ways that you naturally in your programming language have to deal with this kind of thing. And by doing that, you now care more about the semantic nullability of something than you do against the GraphQL nature of nullable to catch errors, please.
All right, so we'll jump back to the Slido here. So some users, some questions submitted from the audience. The top voted one right now is null. Question is from Null. Uncaught type error, cannot read property, question of null. All right, good question. Next this is also from Anonymous. How would semantic non-null work with partial responses like defer and stream? So getting right into the nitty gritty. Anyone?
Yeah, I mean, I think you need that error metadata that tells you about where the errors are in your response to be sort of per payload. I think is the fact, and then that's the place where we know whether the thing has errored is within that payload we computed this response, we know what errored there. So I think that's what we would need.
And to slightly expand on that, the way that stream and defer incremental delivery works is payload after payload after payload. They'll have the data and the errors that occurred during it, or they'll have the incremental is what we call it, with a list of values. So yeah, we'll have the errors there, just as we would currently. So I think it would work broadly in the same way that we currently have it.
And so our next question here is, this is also from Anonymous. What value does adding the current proposal to the spec have, considering it uses directives instead of introducing new syntax, like the original client-controlled nullability proposal had?
So what we have at the moment, and what Jordan's talk covered, is like part of the solution, and it's the part of like introducing the concept of this null only on error. But what I was saying before about the normalized cache, for that we actually need a new thing. We actually want no strict non-nullables to exist for those clients. We don't want anything to be blown up on the server side. We want the client to be able to handle that itself and figure out what it wants to do. Now this has to be an opt-in behavior, because we wouldn't want like window.fetch to have this same behavior. But something like Relay, Urkel, Apollo client, etc., can handle that for us. So for them, they want this new behavior, and this new behavior would require specification. And as part of that, we can also, since we're doing the changes anyway, let's make it more ergonomic at the same time.
Yeah, I'm not sure I understood the question correctly, but I want to just clarify that the spec proposal and the directive are two separate things. So the spec proposal wouldn't be a new directive. The spec proposal would likely be new syntax that like looks, like we have exclamation point for current non-nullable. We would need some syntactic way to communicate this new possibility. So we wouldn't be sort of adding the directive to the spec, but rather adding syntax to the language that has a similar semantic to the directive.
Do you want to talk about the phased rollout thing? God. Okay. Thank you. Yeah, adding new syntax though was going to be a challenge. The stuff we're looking at right now is redefining some of the existing syntax that's used in SDL, which would of course be a breaking change. We don't want to do that. We don't want to do a breaking change. So people came up with a basically document level directives which change the way individual documents are interpreted by the GraphQL validation and execution engine, so that schema authors can sort of do this phased rollout of using this new syntax to describe the nullability for their schema.
And one of the important things from my perspective on that is that a lot of this is, to me, and this may not be an opinion shared by the entire panel, but personally for me, this is very much a server-side concern, and maybe up as far as the client itself, like the people who are working on Relay. But the people who consume it don't necessarily have to worry about this. They're just going to deal with the traditional nullability. It just happens that more of the schema is going to be non-null. That would be nice, right? And then you don't have to do your null checks. So yeah, it's a really nice property of it. And another reason for this, as you say, the document level directive, is it allows us to enable this feature on a file-by-file basis rather than on a schema-by-schema basis. And this is really important because there are so many GraphQL files out there. There are servers that are built from concatenating a whole bunch of GraphQL files together. There are clients that have local client-side extensions to the schema. And if we turn on semantic nullability, or whatever we're going to call it, on the server, we don't want that to immediately have the effect of changing the meaning of all of those existing files. So by opting in on a file-by-file basis, we're not breaking anything. Everything works smoothly, and it all should just work, right? Capital J, capital W, TN.
It'll all just work. So we have next question here is not anonymous from Young. Would you like to ask the question yourself?
Thank you. My question was, how can a client tell if a server supports semantic nullability? And I think you kind of answered this, but follow-up to that is, does the client need to know?
So there's actually two parts to this question. So one thing is, does the server support semantic nullability? And the other question is, does it support this new mode where nothing blows up? Don't blow up mode. So don't blow up mode's really easy. Like, the client can just assume that the server supports don't blow up mode, and it says, please turn on don't blow up mode. And then the server will either respond with, okay, I've turned on don't blow up mode, and here's the response, or it just returns with the traditional response, in which case the client has to go, oh, it obviously doesn't support that. I'll process it the old way. So that's a very natural, you ask for it, and you either get confirmation it's enabled, or you get silence, crickets, in which case it didn't support it. For the semantic non-nullability, that would be handled through introspection. So just how we would normally look at the types through introspection, and we find out what types are involved there, we would look at the types, and we'd see whether there's a semantic non-null in there. But it is a really interesting question, because we don't want to confuse our existing clients by saying, hey, this thing's semantically non-null, and the client goes, what the, what? So what I'm currently proposing is that we look at the mode that the operation is running in, and if it's running in like traditional mode, unless the client has specifically passed an argument that says, I would like to know about the semantic nullability as well, please, we effectively translate it. So semantic non-nullable becomes equivalent to nullable, because from an old client perspective, that's the most backwards compatible way to represent it.
All right, I think we have time for one more question from the audience. And let's talk about everyone who has existing graphs. And the question here is that we've already built our schema, assuming bang more or less means null only on error. What can we do now without breaking changes? Will a future spec save us?
Yeah, I think it goes kind of to Benjie's point about this like ability to translate between the different ones, and like a document level ability to express to be more expressive, right, and to express these 3 types instead of our existing 2 types. So I think there is a path where we have a way that we can express this, and then the existing clients should still be able to get the behavior that they're used to, where things do blow up, and then the smarter, or maybe not smarter, the error handling clients can say, well, look, I'm going to take responsibility for handling those errors. So just give it to me, it's okay if it's null. I'll take care of it. So I think that there is a path forward, and this is definitely one of the cases that we're considering. And if you came to my talk, I actually do apologize that I didn't cover that case. I just didn't really feel how to fit it in. But it is a very important case, and one that's maybe less. It's going to be more reliant on a spec change. Those of us who have started with nullable by default will have an easier time adopting it in this sort of user land experimental phase.
And if your client turns off null bubbling, then all of your strict non-null bangs that you've got already just become semantic non-nulls. So fantastic, but only in that one mode. So use a client that supports it, I guess.
So what's next? What happens now? Where do we go from here? Anyone? And if I'm curious about this, how can I get involved?
Yeah, this is going through the proposal process right now in working group meetings. We have a couple of blog posts that are more or less ready to go out. One for if you're a developer working on a client, and another if you're the user of a client. Benjie touched on this a little bit, but if you're the user of a client, it'll be much less complicated. You don't have to care about most of the stuff that we've said here today. Things will just work. Yeah, you want to say anything? Anyone else? Okay.
I guess just to echo Jordan's point, or as of now, Relay and Apollo Kotlin have like catch and semantic non-null support. So I think it's a brave new world. You can have more control over it. So you should try it out and tell us how it goes, right? Because there are reasons why everything is nullable now. We have theories about why that's good. And now you have the option to not do that. So you should try it and then tell Jordan if you don't like it. And then we can talk more about it.
Well, we are at time. Thank you. A big round of applause for our panelists here. Yeah. Thank you so much, including Lee, even though he got kicked out. But and also for all the work that folks that are not sitting up here have done, working on this over the last several years. And if you stick around in this very room, the next talk is also about nullability from our very own.
Yeah, come listen to my very niche talk. It's very niche, but if you're very into nullability, you might like it.
All right.
Okay.
Thank you all.